My name is Karol Machura, and I'm the product manager, or one of the product manager here at mediCAD HeckTech. I'm located in Bad Homburg, that's near Frankfurt. And today I will show you our spine module. And at the beginning, you should have gotten an email with an access to a remote desktop. So you had the possibility, or you have the possibility to open the software and follow the steps I will show you in a few minutes during the presentation, where you can do the steps by your own. So I think that's a good opportunity to get in touch the first time with the software, and I wish you a lot of fun with that. So if you if you have any problems with reaching the remote desktop, just give me a quick note in the chat, and we will check if we can make it possible for you to reach this remote desktop. When everything is okay and you have the access, just an okay written in the chat would be very nice, that I can be sure that you have the possibility to access the module. That would be great. Okay, so just a few sentences to the agenda. First of all, I want to tell you something about mediCAD at all. So what is the company about? What are we doing? But that will be a very short part. If you have more questions on that, just give me a quick note and I will send you our web address maybe, or I can give you a few more information about that afterwards. And then after the short introduction, we will dive directly into the software and see what we can do with it. Okay, so for the first step, I just want to share my screen. I have a very short presentation. All right, first of all, I want to tell you what mediCAD is about. So this is here a quick overview about what our main modules or our main sections are. So the heart of our company is the pre-operative and post-operative planning. You can use 2D data, X-ray data. You can use 3D data like CTs, MRIs, etc. to plan your surgeries. And we also have the possibility to, we have a web module, so where you have a web access to our modules. So this is the first part. And today, as I mentioned before, we will go deeper into the spine module, and there are the 2D and the 3D possibilities. Of course, treating or preparing or care about a patient is not only done with the preoperative planning and the surgery. We have also working on stuff where you can use the preoperative planning and the data you are created with that into the operation room. I will show you a slide about that in a few minutes. And so, for example, you can use the data on a C-arm or other digital devices. And we are also working on possibilities to use the data you've created within a mixed reality lens. And you will see a few pictures about that as well in a few seconds. So this is our medical device section, and we also have possibilities or solutions for services. For example, 3D printing, logistics, and other stuff. And 3D printing is also in spine very useful, or could be very useful, especially in severe cases where you have the possibility to get a 3D module out of the software. You can export STL files and then send it to someone or to your own 3D printer when you have one in your hospital, for example. Then you can print out the spine or the 3D module, and then then we have a very good view what is the best treatment for the patient, especially in severe cases. So this is that are the main sections: the pre and post-operative planning, the intraoperative solutions, and the services we provide. Another special thing, but I will tell you something about that a bit later, is the query client. This is a link between a PAC system and our modules. So this is a very short overview. Again, when you're interested in that, give me a short note or a hint, and or just visit our website. There's everything explained very deep into detail. So now I will talk something about our spine module, especially the preoperative planning software. As I mentioned before, you have the possibility to plan with 2D data. In this module, the heart of this module is the sagittal balance. You can do measurements, you can do deformity correction, or you can simulate deformity correction, and you have the possibility to put in implants to do any correction or to simulate a correction. And the next section is a 3D section where you can use the CT data, MRT, DVT, so everything with 3D data. And there as well, you can do measurements here manually or automatically. I will show you in a few seconds. You can put in screws and cages manually and automatically as well, and also do the deformity correction. And you automatically get generated a 3D model of a spine. But you will see in a few seconds in the software. So that's are the main possibilities you have in the preoperative planning tool. I just give you now a quick overview about things we are working at the moment. We're working on at the moment. So this is the OR solution I've mentioned a few seconds before. This is the idea of that is that you bring the preoperative planning data into the OR, the operation room. That could be a C-arm, as I mentioned before, or other digital devices. Yes, and as you see here, this is a screenshot of a K-wire guide. You have also the possibility to control the screw you have implanted or you have put into the patient. So this is a demo of an intraoperative X-ray, and this orange lines here are the preoperative planning, and the software matches this information on the intraoperative pictures you've taken. And you also have all implant informations, and everything you've created before during the planning is in the operation room and is available for you to check everything you want to. And this is the idea about the mediCAD OR module. So the last thing I want to show you is the MR, so the visualization of the preoperative planning data via virtual reality lens. And here you see two pictures, not a spine picture, yes, I know, but we will also have functionalities for the spine in the future so that you can have a look at the 3D modules the software creates, or you have the possibility to have a look on implants and how they fit into the 3D module. And then you have the possibility to get this information right before your eye during an operation or during a surgery. Okay, so that was a quick overview about what is mediCAD now and what will mediCAD be in the future. So just a few sentences about our database, because that's a very huge part of our software and of our company. We have a very, very huge implant database so that you have the possibility to plan with the implants you are actually using. So we have 500,000 templates at the moment, and the database become bigger and bigger. So it will be updated monthly, or yeah, mostly it's done monthly. And so if you want the software and see, okay, there's an implant I use, but I don't have, but it's not in the database, we do our best to get this information into the software that you can plan with the implants you're using. And this is a very big part of our software. Okay, so just these few sentences about that. Thanks for the attention. And then I would say we go straight into the software. All right. So you should see my screen. And if you have the, just a moment, I will stop. Okay. Okay, I will share my screen again. So now you should see my screen again. And now if you have the access to the remote desktop, you should see a button like this with an M and something written like Spine 3D 2.6. That should be seen. And then just do a double click on it. And the software should be open. So this is the first window you see normally. And here are a few patient data. Patient data. And as I mentioned before, you have different possibilities to get these information into the software. For example, or normally it's done with this query client, the link between the PACS system and our software. So you can choose via these query client, software written by our own, choose the patient data there and then export it directly to, or open the mediCAD module and then get the patient data there. After the planning, you have the possibility to export it directly to the PACS system, or to export it direct to this PACS system. And then you have it available everywhere you want, in the operation room or wherever. So the first part I want to show you is the 2D module. So I would please you to open this Sagittal balance data just with a double click. Yeah. Or it just needs one click. And then you should see this picture. When you click again on this picture, it's selected, shown by this green sign here. And the first functionality I want to show you is the selective windowing. This is a very useful tool where you can select different body parts where the brightness and the brightness of a few body parts, and select just these areas here. Because as you can see here, here it's a bit too dark, and I can just adjust the brightness to have a better look on the osseous structures. When you're happy with the result, you can just click here on Save and add a new area. And then again, click Box Select. And I will now choose the pelvis here. And again, adjust the brightness. Okay. When I'm happy with that, I can add another one or say, okay, it's enough. I can now just click Save and continue. The next step is a very crucial one. You have to do a scaling. Normally we use a reference object like a metal ball, which has a defined diameter. But if you don't have one, you can also choose, for example, the magnification factor, which you can get from the radiologists, for example. Here we have no ball I've mentioned before, so I choose the magnification factor. You can do the same, just choose this and then type in 90 degrees, click on scale. Then the orientation of the patient has to be chosen. And the rest, the last step is click continue. Okay, now we are in the planning tool. For today, I just want to show you the sagittal balance section. So this is the heart of the 2D module, and the measurements, the deformity correction, I will show you in the 3D part of the 3D module. So please click on sagittal balance. Now we are in a guided sagittal balance determination, let's say like this. And we now have to click or to define a few landmarks. And every landmark you have to choose or to define is described here in the on the left, in the left corner or the left side. So the first thing we have to do is to define the ventral point of the sacrum. So this is the point here. Then the next step is the dorsal point of the sacrum. And as you can see here, and you have just to click with the mouse, with the left mouse button, just one click, and here the next click, and then the software defines or determines the landmarks. So that's the first two. The second are the hip joint centers. It's a bit difficult to see here, but it's a bit dark, and you can see here this bow. And then again, just click one time, click another time, then a circle appears, and now you have to try to reach the acetabulum or the hip joint head, and to define then the hip joints. Here, a line is drawn between the two centers of the circles, and that's our reference points for the other measurements. So the next step is to define the C7 vertebra. You can navigate if you use the mouse wheel by scrolling forward. You got deeper into the picture, and backwards is you got more far away. So you have this is the possibility. And if you want to, if you are very close to the patient and you want to get to the original picture, just click the A on the keyboard, and then you are again at your initial picture. This is very useful. So, and when you scroll in with the mouse wheel, you can define with the cursor where the focus is set. So I now hover with the cursor above the C7 vertebra, and then use my mouse wheel, and we will reach the C7 vertebra. Now I define the top and the end plate of the C7. First the top, and then the end plate. And then I define where to put the C7 plumb line. Normally, or I've seen it a lot of times to do it in the center of the C7 vertebra, but you also can do it at this corner here on the ventral side. But I think that, so you can choose it as ever you want. So I use the center here. Now the next step is defining the femoral shaft axis. This is to consider if the patient is in or is in alignment, or is that you can see if the axis or the obligatory angle is in which angle this bone is. Okay, so the last two steps are defining the lumbar lordosis, first from L1. You can, again, just click one time and a second time, and then again, now from L4, first the dorsal side, then the ventral side. And you have to click to define where this red line is set. So just click again. And now we are ready with the Sagittal balance. Now you can click the G button on your keyboard, and then all the labels here will pop into or to the left upper corner here, and you have now the most important parameters for or to see if the patient is in any misalignment or malalignment, or if everything is okay. So this is the first determination, or now you can get the first idea: is there something I could do to help the patient here? So now you have, of course, the possibility to do more measurements. You can measure distances, angles. You can measure the lordosis or the kyphosis by your own, and have some more other steps. And of course, you can do a deformity correction, but I will show you that in the 3D module. And of course, you have the possibility here to input implants. But this is, again, something I want to show you in the 3D module. If you have more interest in the other modules or the other subsections in the 2D model, just write me a short email, or just write me something in the chat, and then maybe I can tell you something more about that later, or after the webinar. Okay, so this is the main functionality for the 3D module. You have here on the right side informations about the alignment of the patient. The first step is to have here the anatomical measurements. So this is regarded to the landmarks we've set. And when you do any correction simulation, the parameters here will alter. So when you just correct the alignment here, all this parameter will be adjusted so that you can reach a more healthy alignment of the patient and have an idea of what you can do during a surgery, for example. All right, so when you don't have any questions about the 2D module, or if you have some, just write the question in the chat, and I try to answer it. If not, we can just go on to the 3D module. Okay, no questions so far. So I will go on to the 3D module. So if you want to do the steps I've done, or I will do now in the 3D module, please choose the patient with the patient ID 20 here. Once again, click on that. And here we have a patient with a osteochondrosis between L4 and L5. I just click here on the X-ray. And when you click here on the blue eye, you can have a look on the data before you open that data up in the module or in the software. And then you have a closer look on that. Okay. So this is a post-operative, a pre-operative X-ray, and here we have the post-operative one. So this is what the surgeon, the doctor have done. All right. So, but now we want to concentrate on the CT data. This is a pre-operative CT data set. So I just again click on that, and now it's selected, shown by the green symbol here. And the first step I want to show you is the segmentation of the software. So here the software automatically determines crucial landmarks and build up a 3D module. And as you can see here with the purple color, this is what the software determines as the vertebrae. And this is important later for every automatical measurements or the automatic implant input or the automatic screw placement, etc. So it should look like this. And when I'm okay with the result the software creates, I can click just accept and continue. If the segmentation isn't done yet, you just have to click on start segmentation, and then the segmentation should be done by the software automatically. I wait just a moment if you are on a remote desktop where the segmentation isn't done yet. But then just click on start segmentation, then accept and continue when the spine looks like this. When not, just write it on the chat. Okay, so I click on accept and continue. And now we are in the working area again. So the initial data was an axial data set, and the Sagittal and the kernel data set is created by the software by itself. And again here, the 3D module. Now you have different possibilities to navigate through the data. Here again, when you use the mouse wheel, you can go through all planes. And you can see the cursor here alters now, or has another, after or when using the wheel, the position of the cursor alters. And this shows you where you are in, or in which plane you are. You can also click the right mouse button and hold it, and then you can go through all planes very quick. You can use the mouse wheel. This is a bit more precise, or you can use the right and hold mouse button, and then you can go very fast through the planes. When you click Alt on the keyboard, then this circle should arrive when you are in the right upper corner of the coronal view, or it doesn't matter. You can choose one corner, and then when you hold the Alt button and then click the right left mouse button and hold it, you have the possibility to alter here this angle of the view. This is a very useful function when you consider, or when you try to treat a scoliosis case. Maybe we have a few minutes at the end of the webinar where I can show you that. Okay, so this is one possibility. If you want to go a bit deeper into one section of the picture, you have here again different possibilities. You can choose, of course, this navigation, so you don't have to use your keyboard. You can choose the navigation button, just click on that, and then you have the possibility to zoom in by holding the left mouse button. Then you have the possibility to move everything. All right. And again, when you want to rotate everything, just click the Alt key, or the Alt key on the keyboard. So now we want to have a look on the pathology here. As you can see, between L4 and L5, the space between the two vertebrae is very closed. You can see if you that very clear when you go through all the planes. Here the space is very it's not existing anymore. So So we have now different possibilities to treat that case. I want to show you a very quick way to do that, because I know do a preoperative planning in spine surgery shouldn't take a long time, especially when treating not a severe deformity or something like that. So you have first the possibility to put in a cage. So this is the treatment the surgeon who has treated this patient decided for. And you have different possibilities. You can do that fully automatic or do it manually. So just click on manual cage placement. I want to show you this case. Just click on that. Now you have the possibility to choose between which vertebra you want to put in the cage. So we have the osteochondrosis here between L4 and 5. So I choose L4 and L5. Choose the manufacturer. This is the list of implant vendors we have for the spine at the moment. I would please you to take Cygnus, for example. You can choose every you want, just to have a look how different it could look like. But I take Cygnus, I take the Novel cage. Here you have the possibility to choose a cage with lordosis or without lordosis. And now define the height and the length. You have, of course, the possibility first have a look how the height of the other vertebra spaces is, to have an idea how high your cage should be. I take, for example, a height of 10 millimeter, a length of 19 millimeter. I can choose now the lordization, for example, 5 degrees, and the width, let's take 44 millimeters. Now I can just click Insert Cage. And took a few seconds. And now the software inserted the cage. You have now different possibilities to have a look on this cage. So you can have a look in all planes and directions. And you have special possibilities. For example, when you're clicking here on transparent view, you have a transparent view on the spine, and a closer look if the dimensions of the cage is correct, or maybe it should be a bit more smaller or bigger. So you have here different possibilities to check if that's the right implant. And all things you do, so choosing an implant or measure something, is shown here in the result window. So you have here the manufacturer, and you have here the dimensions of the cage. As an information you can give to the operation room, to the colleagues in the operation room, so that they can prepare the surgery maybe one day before or something like that, or a time before. Okay, so this is the first one. I can now insert a second one. Okay, now a question. Yeah, I will show that. So I want to put in screws now, if that is something you want to see. The question was, is there a clinical case with a fixator interne? So I would show you now the case with screws, and then after I have a case with a scoliosis, but I'm not sure if we have that much time to show this. But maybe I can do that. I would just show this case till the end, and then we can see how much time we have left. Okay. All right. So I've put in the cage now. I can choose another one. So the section above, for example. I use the same one, 10 millimeter. Okay, and here again, I have the possibility to have a look on everything, if everything is okay. Of course, I have the possibility to adjust the cages if I want to. So to reach higher lordosis, I can see if the dimensions of the cage is good when I put it a bit more to the ventral side to reach a higher lordosis, and then have here a look again on that. I can do it in this, or I can again use the glass view to have a better look or more detailed look on that. All right. So the last step would be to put in the screws. Sorry for that. So I leave the submodule now and would choose now the multiple screw placements. I have now the possibility to choose monoaxial or polyaxial screws. I leave it here, select the polyaxial screws selected. Again, choose the manufacturer. Decide now which vertebra I want to consider. Let's say I want to choose L3 to L5. Choose both sides and insert the screws. Okay, now the software automatically inserted the screws, and I have now the possibility to go through the planes here on the axial view to see if the if everything is or if the dimension of the screws are okay, or if they are maybe in the diameter too big or too small. And then I can go through all planes. Can have here a look on the cage, if everything is okay, or if it's too big or too small. And yeah, decide if everything is okay or not. And here again, you have all information about the implants on the right side in the result window. Of course, if you are not happy with the dimensions of the screws, you can click with the right mouse button here on Edit. Take a few seconds. And then you have the possibility to adjust everything. If you want to, you can see how the screw would be shown when you alter the angle in the axial view. You can also alter the angles in every other plane or in any other views. And you have the possibility to alter the length, the diameter, as you want to. I choose one with a smaller length, click on change screw, and it will be changed automatically. So, and here again, I can go through the planes and see, okay, oh no, with a bigger length, and I see, okay, this is a bit too long, I guess. So I can just adjust that again. And now I have an idea what I could need for the surgery. So again, okay, that looks much better. All right, so the last step now would be to input the rods. The idea or the information I get now from the software is the length of the rods. I leave the module. When you have left the module and here the buttons are a bit confusing, or the labels are a bit confusing, you can just click on L on the keyboard, and then all of the labels will disappear. And now you have the possibilities. You can have a look on the rods. So what the software has done now is to define the length of the rod, not the bending. This is a functionality we're working on at the moment, but you have not the possibility to consider the bending. But you have an idea about the length, and that is written here on the result window as the other informations as well. So that would be the treatment of that case. So you have now the possibility to check everything again, but when you're happy with that, and you say, okay, all the diameters of the screws is okay, and the cages are okay, you can export everything. So click here just on print and export. Takes a minute. So, and it's a bit small. Okay, and now you have here all information about the patient. You can type in here information about the surgeon. Here you have all information about the implants you have chosen. And this is something you could print out and give to the colleagues in the operation room, and then they can prepare, for example, the implants. And here you have the information about the length of the rods. So this is again something you can prepare before the surgery takes place. Okay, so you can print it directly, or you can export it. Normally, when you have access or when you have a link to the PACS system, you have here this button, and you can export all information you've created during the planning directly to the PACS system, and then have it available in the operation room or wherever you want to. So now this button is gray. It should be gray. Should be gray as well when you're now in the module, because I think you don't have any access to a PACS system. Yeah, but this is possible. So when we install the software on your system or in your hospital, you normally have this possibility or this functionality. So this is one possibility to treat something like that. I will show you So any questions till now, or any questions about the functionalities you've seen so far? I hope this case or this fixator intern case is okay for you. Or did you expect something different to see? Okay, thank you. Right, okay. So this is the first case. I want now to go to the scoliosis case. When you don't have any questions so far. So please choose the patient with the patient ID 70. Again, click on that. Click on segmentation to assure if the segmentation is done. Okay. And it should look like this. Again, when the segmentation isn't done, just click on Start Segmentation. Then it took a few moments and it should be ready. Okay, so I click on Accept and Continue. Now you see here the scoliosis case. First functionality I want to show you is when you have this data and you can see here some parts of the table left, but you have here the possibility to click on Image, then Remove Table, and then click the Auto button. And the software automatically cuts out the part of the table. And you have also the possibility to cut out bony structures. So just click on Image, Remove Table, and then on Manual. So you could cut out the table by your own, but you can also use this functionality to cut out osseous structures to have a better view on the spine. So just take or just choose this delete button here. And then you have to click and hold the left mouse button. And you can see this red area. And when you release now the left mouse button, everything in the area will disappear. So now you can click again on delete and cut out everything which you don't want to have in the data set. For example, like this. Okay, well, when you're finished with that, just click on Exit. And now you have a better view on everything on the spine. So when you click on the mouse wheel, you have the possibility here to go through the different planes. So you have some soft tissues here. Click on the mouse button and go up, and then all of the soft tissues should disappear. And you have a better view on the osseous structure of the spine. All right, so yeah, normally you also have X-ray of scoliosis case, and we have here a cool functionality. So you have to click, you have to click the Shift button on the keyboard, and then these two green arrows should appear. So click, push the button, the left Shift button, and then click and hold the left mouse button. And by shifting from right to left, all the planes should be overlaid, or so all X-ray layers are overlaid, should be overlaid, and then you have something like an X-ray of the spine. So this is the data for at the beginning. You can go through all the planes, but by clicking Shift and the mouse button, you have the possibilities to see every plane at one time, to have a better view on the scoliosis case. So something like this. And here you have the possibility to measure, for example, the Kopfwinkel of the scoliosis case. I will choose now the auto button, choose between which vertebrae I want to measure the angle. Let's say the upper could be T11 or T10. And I would choose now maybe L3. And then you can turn on the interim results, but in this case, I think it doesn't make any sense. So just click on Start. And then you have information about how the angle or the Kopf angle could be. So you have to consider the anterior and the angle of the anterior plane. So this is the Kopf angle here. To have a look if everything is okay, you have go through the planes, and when these yellow just a moment. When this irregular distance appear, this is the plane where the Kopf angle is measured. So this is the upper plate of T10. And here, this is the end plate of L3. So this is, and here is where the angle is measured. Now you have an idea about the Kopf, where the Kopf angle. You can now make the labels invisible again. And now I have the possibility to, now you can decide what's the best treatment for the patient. You have the possibility to simulate any deformity correction or any osteotomy. For example, to a closed wedge osteotomy here. Click on Apply. And then a cut will be executed by the software. This is one possibility. You can alter the cut you've done. And when you're fine with that, the angle of the cut is shown here. When you click on deformity correction, you have the information about the cut here. And but if you don't want to do any osteotomy, you have the possibility just to put in the screws again. So I choose the multiple screw placement and decide or choose the implant bender. Then decide from which vertebra to which vertebra I want to put in the screws. 11 to L3, for example, and again put in the screws. So now the software tries to determine the right pedicle diameter or the right pedicle length. And when we don't have any screws with the right diameter, the software gives you information about that. So, okay, you don't have any screws in the database with the right diameter, but you also, of course, have the possibility to put it in. And to have a look if the diameter is okay, or if you choose or should choose another diameter. Yeah. This is just a hint of the software that there's possibly no fitting screw. So, but I want to show you the monoaxial screws, because we have, if you don't want to use any of the implant vendors we have in the database at the moment, you have also the possibility to use dummy screws. So choose the monoaxial type, and then you have the possibility to choose here dummy. So this is no special screw. This is just a dummy screw from not a special vendor. T11 to L3, both insert. And here again, a hint from the software. But then you have an idea, or you have now a hint. Could be that the pedicles are maybe a bit too small for a screw, but you have the possibility here in the software to check this. So I would recommend to alter here the angle, that you have a better view on the screws. And now the software, okay, tries to determines the right direction and the right diameter of the screw. But as you can see here, the pedicle diameter is very small. And you can now decide, is that okay to put in a screw here, or should I should I choose another treatment, or other treatment here? And here again, you have the possibilities to go through all planes and see if that fits or not. You can check this on this plane. You can check this on the sagittal plane, if this angle is correct. And even if the software doesn't figure out the perfect direction, or the perfect direction of the screws, you can get an idea if the length and the angle is okay. And then you have an idea what you should or could do during this, the surgery. So that this is something like a preparation for that. Okay, so let's say when you can just have a closer look on T11, for example. Again, there are the same possibilities you have with the cage. You can see here in this plane, or in this CT data, everything is okay or not. You have also here the transparent view. And something which could also be very useful is the clipper. I'll show you that. I leave the module, click on A to get in the first view. And then I go to the image button, click on that, and click Create Clipper. Now I have this green box with an arrow in it. And then I click the left mouse button and hold it and define a box now. When I release now the left mouse button, the clipper is created. So I can now alter the direction of the spine, and then I can alter the height or change the height of the box, and then have a closer look here on the 3D module. Bring back a bit of the soft tissue. And then I can have a good view if, so if that is a bit too small, you can double click on the picture and then you can have a look from this plane, for example. And now you can see maybe this is a bit too big or too small, and or this is too small or too big, and then you have a better view on, or you can, a better view if the screw, the diameter of the screw, is okay or should be shorter, or the diameter should be smaller, something like that. As you can see here, I think this is a bit too long, the screw, so you can alter here the length and the diameter as well. And again, you can now go through all the stuff, or to all the screws. It took a bit time, but you have a good idea about what you could expect during the surgery now. Of course, intraoperatively, things could be different than you've figured out before or figured out during the preoperative planning. But now you're prepared, or you have an idea of what could be expected. So, and this is also the idea of our software, that you do the preoperative planning or the preoperative plan and be prepared as good as possible for the surgery. Even if you don't have any navigation system or something like this. And you have the possibility here to take pictures, screenshots. You just have to click on snapshot. You can save this view on a local folder, print it out if you want to, or save it to the export. Let's click save it to the export. And then here again, if you click on print and export, you have here again all the information about the screws. And here about the cup angle you've measured before. And when you simulated osteotomy, here the information about the osteotomy would be shown as well as the angle or any other measurement, any other measurements you have done during the planning. All right, so that are the 3 cases I wanted to show. Thank you very much. And I hope we will see us again. Bye.